All right, what if I told you that you could create a custom touch interface just by hitting print? Seriously, imagine designing the exact controls you need for, well, anything, and just printing them out on a piece of paper. Sounds like something out of a sci-fi movie, right? Well, it's not. It's exactly what some brilliant researchers at Rutgers University have figured out. So, let's dive in.
Okay, just take a look at this. Wow. Over here, you've got a custom set of controls for a phone, literally printed on paper and clipped right onto a steering wheel. And then, look at this, a full QWERTY keyboard, completely foldable and portable, all just printed with some special conductive ink. This isn't a concept drawing, it's a real prototype, and it just makes you wonder,
Yeah, how in the world does a plain old piece of paper become a complex, multi-button touch interface? Think about it. Printed in one go, with absolutely no extra electronic bits and pieces stuck to the paper. That's the big mystery we're going to unravel right now. But to really appreciate just how big of a deal this is, we first got to understand why it's so darn hard to do in the first place. Why isn't everything a custom touchscreen already?
well, the traditional ways of doing this are a total headache. You're talking about complex assemblies with multiple layers that have to be perfectly aligned. It's so tricky. And if you want more buttons, you guessed it, that usually means more wires, which just creates this tangled, complicated mess. Some other methods even need bulky hardware like cameras or projectors that are a nightmare to keep calibrated. So the bottom line is, up until now, making these custom interfaces has been super expensive, really complicated, and just not easy for anyone to do. So the researchers behind this paper came up with something radically simpler. They found a way to sidestep all those problems with an incredibly elegant, single-layer solution. And this image just shows it perfectly. The entire circuit is printed in a single pass with conductive ink. That's it. There are 0 components you have to mount on the paper itself. All the brains of the operation, the microcontroller, the electronics, they're all packed into this little clip-on device. It just attaches at 3 simple points. It's so simple, so clean, and so easy to reproduce. So, how does it all work? Well, the secret sauce here is turning what's usually a bug into a feature. See, this conductive ink actually has pretty high electrical resistance, which you normally don't want. But in this case, they used it to their advantage. They printed this long, snaking track that basically acts as one long, continuous resistor. So when you touch a button, you're essentially tapping into a very specific point along that resistor, giving each and every button its own unique electrical address. Okay, but this elegant, simple system runs smack into a huge, unpredictable problem. And that problem is you, or more specifically, your finger. It's the very thing that makes the whole system work, right? But when your finger touches the paper to close that circuit, it's electrically very, very messy. And this, right here, is where the real genius of this whole thing kicks in. The researchers had to solve this massive puzzle. How do you get a clean, consistent signal from a totally inconsistent source, the human body? And their solution? Oh, it is just fantastic. So, the villain in this story is something called skin resistance. It's all over the place. It changes depending on the person, how hard you're pressing down, even how sweaty your hands are. Get this. The researchers measured a range from 500,000 ohms all the way up to 65 million ohms. That is a gigantic range. With that much wild variation, trying to tell 2 keys apart with a simple voltage measurement, it's pretty much impossible. And this comparison just lays it all out. On the left, that's what the raw voltage readings look like from different key presses. It's a jumbled mess, right? They're overlapping, they're unreliable, you can't make sense of it. But then look at the right. After they work their magic, the value for each key is super clean, totally consistent, and incredibly easy to distinguish. So what's the trick? The technique is called polarity switching, and it is a brilliantly simple 4-step dance. Okay, first, the system measures the voltage. Then, and this is the key part, it instantly flips the electrical polarity. Positive becomes negative, negative becomes positive. Then, it takes a second measurement. Finally, it just calculates the ratio between those first and second measurements. And here is the magic trick. When you do that calculation, that wildly unpredictable resistance from your finger, it gets mathematically canceled right out. You're left with a pure, stable number that only depends on where you touch the paper. It's genius. Okay, so that's the theory, and it sounds amazing. But how does this clever trick actually hold up in the real world? Well, they had to put it to the test. Check this out. For a standard 10-key layout, the system hit a touch detection accuracy of 99.6%. Let that sink in for a second. That is near perfect accuracy from a circuit printed on a piece of paper and read by a little clip. That's just incredibly impressive. Now, of course, it's not perfect. There are some limits. As you can see from this chart, as you start cramming more and more keys onto the paper, the accuracy does begin to drop a little bit. For 15 keys, you're still looking at a very solid 93.5%. Even at 20 keys, it's holding strong at 91%. And that makes sense, right? The more keys you add, the smaller the electrical space between them gets, which just makes it a little trickier for the system to tell them apart. And I really appreciate that the researchers were super open about the kinds of errors that pop up when things get more complex. Sometimes a press just gets missed completely. A little more often, especially with lots of keys, it might think you hit the wrong key, or a single press gets registered as a couple of different keys while your finger is settling. But honestly, for so many custom uses, this level of performance is way more than good enough.
And that really brings us back to the whole point of this. This isn't just about making cheap keyboards. This technology opens up a whole universe of creative possibilities. I mean, just imagine interactive kids' books where touching a word reads it out loud. Or think about custom-printed controllers for music software. Or even smart paper ballots and interactive surveys. The sky's the limit.
So, what's the big takeaway here? What does this all mean? Well, I think we're looking at the very beginning of a potential revolution in how we design, create, and interact with the smart objects all around us.
And, I think the researchers really said it best themselves. They said they hope this technology inspires creativity in interaction design, kind of like how 3D printing led to this explosion of smart object designs. And that's such a great way to put it. 3D printing gave everyone the power to prototype physical form. This gives us an easy, accessible way to prototype physical interaction. This completely changes the game for anyone wanting to quickly prototype a user interface. It takes this power out of expensive, specialized labs and puts it directly into the hands of designers, students, hobbyists, anyone with an idea. So really, the final question isn't just about the tech itself. It's about what you would do with it. If you could print any interface, any set of buttons for any device, what would you make first?